Um, Good morning, good afternoon, everyone. This is the roundtable session for e-posters for session 5.2, experience with and possible additional contributions to issues of global concern, such as disaster risk mitigation, climate change, and sustainable development goals. So my name is Roland de Braz. I'm the convener for the session. Sitting next to me is Azan Korbani, who is going to do the question handling from the audience. So again, welcome. And the way that this is going to proceed is that we will ask each of you to present your e-poster. You will have 2 minutes to do this. And we will call your name. We have a list. This is a session where there are very many, because of the topic, there are very many different kinds of technologies involved. And so we have tried to group them by technologies, and we will call your name. And please share slides, PowerPoint or PDF, but no videos, please. That would be too much for the bandwidth we have. So we call first Mr. Valery Nikulins. Valery?
Yes.
You're on.
You can see my presentation. Oh.
We cannot see it yet, Valery.
Oh.
So there should be a share button at the bottom.
You can see my presentation?
Not yet, no.
No?
No.
No. Oh. Sorry. No. Oh, okay. Okay.
Okay, we can see it now. Thank you.
Okay, thank you. Dear colleagues, our presentation is dedicated to introduce earthquake and one of the methods that can be useful in these cases. You can see the main presentation. Technological progress has led to the emergence of the new class of seismic events provoked earthquake. They arise even in stable continental condition. These phenomena are especially unfavorable near environmentally hazardous energy facilities. This study provoked example of such earthquake on the territory of East European platform and North American platform. The main problem is the search for effective discriminants. The object of the study was the seismic moment tensor and its parameter for induced earthquakes with relatively small magnitude, 2.6 or 4.0, on the territory of ancient platform. The problem for the studies is a rare seismic network in the area of the East European platform and small magnitude of induced earthquake. The matrix method was used to simulate the propagation of seismic waves in layered media. The theoretical results for the displacement field of the free surface of the layered half space were used to calculate the seismic moment tensor and determine the source mechanism. Using the waveform inversion methods to obtain the seismic moment tensor, it became possible to estimate the duration of the process in the earthquake source time function for the small magnitude. The duration of process is the source of the induced earthquake in Canada with magnitude 4.0 was about 4 seconds. The duration of the earthquake depends on the magnitude. Earthquake from magnitude 5 to magnitude 6 lasts up to 30 seconds. For example, with low magnitude, the STF function has hardly been studied. This is due to the complexity of the determining the seismic moment tensor.
But you are already at 2 minutes. Please wrap up. Thank
yes, only 2 words. Fuse studies are associated with the accumulation of statistics of both provoked earthquake and natural earthquake for platform territories, so solving for the focal mechanism using the original wave inversion method by Malitsky and comparing the STF function for natural of induced earthquake. Thank you for your attention.
Yes, thank you. Thank you. Very interesting presentation. We'll get back to you with questions on this. We have 1 hour altogether, so please try to stick to 2 minutes if possible for your presentation. So the next one is Umar Kadiri, but I do not see him on the list here. Umar, are you? Haven't joined us. Okay. So the next one is Belinda Walkahi, but I'm not sure she's here either. She hasn't joined us from she hasn't joined us from the Solomon Islands. Next one. Next one is Professor Shanker. Professor Shanker, you are on for your presentation.
Okay, thank you.
Yes, we can hear you.
Professor Ronan, I am just sharing my slide. So
okay.
Let you see it is coming.
We want to make sure that, yes, we see your slides now. Thank you.
I, Professor Dayasankar from Department of Earthquake Engineering, Indian Institute of Technology, Roorkee, India. My topic of presentation is trending discussion on Indonesian tsunami of September 28, 2018. The most disastrous hazard associated with earthquake is tsunami. It has often caused widespread devastation, leading to serious human, environmental, and economic losses. These devastation and losses can be reduced by building resilience in tsunami early warning system and hazard mitigation strategies. In this poster, you will find a comprehensive discussion about 28 September 2018 Indonesian tsunami. Although in the year 2018, Indonesia faced 2 tsunami, one September 28 Palu Bay in Sulawesi. The origin of this tsunami was earthquake of magnitude 7.5, while other December 22 in Enak Krakatau in Sunda State. This was generated due to the volcanic eruption. Collecting various tsunami catalog from 1500 to date, tsunami hazard are estimated for cause, maximum magnitude, water height, casualties, etc. CTBTO's IMS network data may be useful for tsunami warning and hazard mitigation strategies. I invite you all for this session. Thank you.
Thank you very much, Professor Schenker. The next one.
Thank you.
Thank you very much for a very interesting presentation. So, there will be some questions, I'm sure, about your poster. So the next person is Dr. Shani Kadmiel. Hello.
Yes,
hello, Shahar.
hello.
On.
So can I share my screen?
Yes, please go ahead.
Can you see my slides?
Yes, very good. Thank you.
Let me just go to slideshow. Yeah. Is that good?
Perfect.
Okay, so good morning to everyone. The e-poster I'm presenting today is following a paper that we published early this year in EPSL. So it's open access. I encourage you to click the link on the poster and have a look at the paper. Following the magnitude 7 2010 Haiti earthquake, the shake map was estimated solely on distance from the epicenter, and this is because there were no seismometers on the island of Haiti during this event. This resulted in an overestimation of the damaging zone around the earthquake close to the epicenter, and an underestimation of the geographical extent that this potentially damaging shaking might look like. 7 years after this event, the USGS updated this estimated shake map, and this is the figure you see on the right. And there are noticeable differences. And this map was updated based on surveyed damage on the ground, and it was updated to reflect this damage that was surveyed on the ground. What we did in this study is we used infrasound recorded by an IMS array all the way on Bermuda Island, more than 1,700 kilometers away. And we used these recordings to back project them. We calculated the acoustic intensity and we back projected that to map the acoustic intensity shaking around the epicenter. And what I plot here in green, which I hope you can see, are the contours. So the dotted contour is the contour of the Mercalli intensity 5 from the initial map. If I can go back, yeah. So it's resembling this contour, and what we show in our in our back projection is that we actually cover a region that is much closer and resembles much more the contour from the updated map. We can also use this information to retrieve the polarity and the radiation pattern around this earthquake, and I think to that extent, this is quite unprecedented. So I encourage you to follow the rest of the poster, and let's have a discussion in the video rooms later if you have questions. And I encourage you to also have a look at the paper. Thank you very much.
Thank you very much. Very interesting, Shahar, indeed, application of infrasound on sources. The next speaker, I think, will be Umar Kadiri. He joined us just now, so we'll go back to the order, I think, joining us from Nigeria, right, Umar? We cannot hear you. I think you're muted. You're muted, Umar. Okay, can you try now?
Hello? Can
Oh,
you
yes,
hear me?
now we can hear you now. Yes, perfect.
Okay. Yeah, good morning, Ronan.
Morning.
Hello?
Yes, go ahead.
Okay.
So do you want to share a presentation, or do you want to speak about your e-poster?
Yes, I can do that.
Very good. So you have 2 minutes. Please do not share videos. That's a little bit too much for the bandwidth. Okay.
Hello?
Yeah, we see your slides. Very good. Yeah, I think we may have a bandwidth problem. So if you would cooperate, and we'll stop our video ourselves, and if you could cooperate with us to stop your videos, thank you. Okay, Umar, we lost your audio now.
Hello, can you hear me now?
Now we can hear you. Yes, thank you. Go ahead.
Okay, let me quickly give my presentation. Umar from
Yes.
from Nigeria.
Yeah, you can maybe make it full screen,
Okay.
and you have 2 minutes. Go ahead.
Good morning.
Good morning.
I'm going to give a talk on seismicity. Yeah, it's a full screen now. Okay, I'm going to give a talk on the seismicity and seismic hazard assessment we did in West Africa recently. My co-author is Professor Kichko. Our research basically is to address two basic issues. Number one is and the lack of consensus as to what type of seismicity West Africa actually belongs. And secondly, we also looked at the seismic hazard assessment for the whole of West Africa for the first time. So in addressing these issues, we updated the earthquake catalog for West Africa between 1615 to 2020. And secondly, we used a method of maximum likelihood estimate, a MATLAB program developed by the authors to compute seismic hazard parameters, including the PGAs, using both a historical and a complete part of earthquake catalog. So our findings confirm that West Africa actually belongs to stable continental crust, as opposed to other school of thought that the region belongs to shallow seismicity. Also, we achieve a seismic hazard assessment for West Africa using different zones with different level of completeness. Please, you can visit our poster for detailed information regarding this issue.
Thank you very much, Umar. Interesting assessment of the seismicity in West Africa. So I have a couple messages for the audience who is listening to us on the Super Event app. You can ask questions on the chat, and we will monitor them from here and ask the authors of the e-posters in the remaining time. Thank you, Umar. So the next, if you could stop sharing now, we will go to the next speaker, who is Mr. Assad Ur-Rehman. See him on the list. So we will go directly to Miss Zile Huma. Miss Huma, you're on. Can you hear us, Miss Huma? You are muted. Hello, Umar. Is it possible for you? Okay, thank you. Yeah, Miss Humar, I think you are still muted. Make sure your mute button is on, or your microphone is on the application. And you can turn your video on, maybe. Well before.
Can you hear?
Yes, we can hear you now. Please go ahead.
Yes, can you hear?
We can hear you. We can hear you. Yes, Ms. Huma, we were able to hear you for a while, but we cannot hear anything at this point.
Yeah. Can I start?
Yes, go ahead, please. Oh, are you expecting us to share? Are you expecting us to share something? I think we lost Ms. Huma, unfortunately. So it might be some bandwidth issue. Maybe she tried to share something and that caused her session to stop. So let's go to the next speaker then, and then we'll come back to Ms. Huma if she comes back online. So the next speaker is Aaron Gutierrez. Aaron, can you hear us? Hello, Aaron. Can you say something? Can you share your screen? It's not. Okay.
Hello, good morning.
Yes, good morning, Aaron.
Sorry, I had a problem with the mic. I will share my.
Okay, great. Thank you.
Did you see the presentation?
Yes.
Yeah, good morning, everybody. I'm going to speak about my poster that is about the Taal activity on 2020. It has a big options that is a column about 10 and 15 kilometers. We have to say that Taal volcano is one of the more active volcanoes of Philippines, and in the average, the explosions reach the level of 4 in the volcanic eruption index that is measuring, trying to measure we can say the magnitude of the eruptions. Most of the eruptions are phreatomagmatic as they have contact with water, as there is a lake in the crater, but also in some layers above the volcano. And in this case, we were lucky, really, because we had the TGY station just about almost 12 kilometers. So this is not very common. And yeah, I have to say that is a broadband seismometer. And in the results, there were 260 LEV, associated with the main activity in the lap of January 12th to January 13th. That was the main activity, the days with the main activity. And the magnitudes were about 2.9 and 4.4. And as you can see, most of the epicenter were located in the southeast flank. Yeah. In this case, I'm talking about LEV, but we record also another events that just were recorded by JY. And we can catalog these events like volcano tectonic. Yeah, they were very impulsive. Yeah, and we have also that what could be a very strong BT, or an explosion. This is difficult to know because the station is very close. So, but also there were several low periods events, as we can see, very low frequency. And also a lot of interesting events like hybrid that were starting with high frequencies, and then the low frequencies were dominant. That means that some cracks were done and then filled immediately with some kind of fluids like gas or magma. Yeah, and we also record two infrasound events. Yeah, the first one were 4 stations, and the second one were more powerful. And yeah, more than a 6 station record this event. When the lesson here is that in this case the activity was operated in 4 hours, was increased suddenly with not too much remarkable seismicity. So and to install a station very close to the volcanoes, or the most active volcanoes, will be.
Please wrap up, Aaron. It's already been over.
Okay.
Thank you.
Okay, thank you.
No, we can wrap up. You were starting to do that already.
Okay, let me stop. Okay. Yeah. It's done.
Thank you very much, Aaron. I think we went over everyone's presentation who's present in the roundtable, and so we can go now. We are preparing Miss Zile, who she left us for a while and she joined us back. So we'll try to see what we can do in terms of sharing her presentation. We're not supposed to do that, but we'll try to our best to nevertheless. If you did want to just speak about it, Ms. Huma, you can go ahead and speak about it as well.
Okay, sure.
Okay. Why don't you go ahead and do that then?
Okay. Hi. So I'm presenting the presentation on the which is a close link between the nuclear weapons and the climate change. The scientific revolution made human lives very easy, but created so many problems. So if we look at some of the disasters caused by the climate change and the nuclear testing and explosions, we can see that impacts that are the problem for several sustainable development goals. Like if we go for the climate change, like they cause the floods. Like if we take the example of the floods, they cause destruction to the human life, infrastructure, the cause of the many health problems. Similarly, if we look at the nuclear testing, there also damages the human life, infrastructure, and source of many health problems. So if we look at our sustainable development goals, so I have found a close connection. And if we look at the sustainable development goals, so the negative impacts which are caused by the climate change and the nuclear explosion are a big problem to achieve the sustainable goals, like no poverty, health, gender equality, life on land, and life below the water. They are damaging all these sectors. So I would like to come up. These are some of the goals which I have explained given on these slides, like how the nuclear testing and climate change are the big hindrance to achieve these goals. So I have suggested some of the recommendation which I would like to put forward in front of all the viewers. First of all, we need to have a complete global disarmament. I mean, you cannot dictate some nations to disown the nuclear weapons. We have to achieve this disarmament at all levels, whether they are the big powers, medium powers, or the small nations. So we need to develop consensus on this. And the second recommendation is that we need to have put more research in these areas to highlight what are the negative impacts of climate change and nuclear testing and weapons. And similarly, we spend a lot of budgets on nuclear testing explosion, which can be utilized to achieve these sustainable goals. Similarly, the public diplomacy is very important, because when you talk to the people, when you can develop a global consensus, which can help all the nation to achieve those goals. Similarly, we need to invest more budget in the research areas on the climate change, negative impacts of the climate change, and the disasters which are caused by the testing and explosion. And we need to strengthen our global institutions which are working on these issues, that how we can make a collaboration between the advocates who are promoting to play our part to mitigate the effects of climate change, and on the other hand, the people who are advocating that nuclear testings are a problem for the humanity or the global existence even. So such institutions can play their part to raise the awareness and develop this consensus. So, and last, the most important, the public diplomacy, the student-to-student contact, the media contacts, and the professional contacts to raise awareness as well consensus on this particular issue. That is very important. So this is the final my conclusion, that climate change and the nuclear testing, they both have the close link. They both are damaging the humanity, and we need to develop a consensus at the global level, at part of all the nations, to take their part to reduce the climate change, as well as work for the prohibition of nuclear testing to achieve the sustainable development goals. Thank you.
Thank you very much, Ms. Huma, for a very inspiring talk. So we have presented, you have had the opportunity. Hello again. We have had the opportunity to watch all the presenters now in this session, and I remind you that we also broadcasted on the Super Event app, so we might get questions from the audience, or the audience. So I suggest that first we do a roundtable in terms of if anybody has questions for your fellow presenters in this session, to go ahead and ask the question if there are any for your fellow presenters. So I think you can raise your hand virtually on this application by using the icons on the bottom. Okay, so to get this going, what I will do is ask a question to to Zile Huma. I hope I pronounce your name correctly.
Yeah.
Thank you very much. That's very inspiring, of course. You mentioned complete nuclear disarmament as a goal. Do you think prohibition, which is the goal of the CTBT, prohibition of nuclear testing is a necessary step in the direction of complete nuclear disarmament?
Well, I think the prohibition of nuclear testing, and if we want to have the complete disarmament, prohibition of nuclear testing at all levels is very important. We cannot dictate the small nations to do not have small or middle powers to don't have the nuclear weapons or testing. In fact, we need to develop this consensus at all levels, the consensus at all levels, whether they are the big powers, whether they are the small nations, or whether they are the middle power nations. So unless, because every country needs their security, if you lost some countries to have the nuclear testing or develop their nuclear weapons, and the other nation to the other nation you dictate them to disown them, then we cannot achieve this goal of disarmament. So prohibition of nuclear weapons at all levels, whether they are the big nation, whether they are the small nation, equal disarmament, equal policy we should have to achieve this disarmament goal.
Okay, thank you very much, Zile.
Thank you.
And are there any questions for any of the presenters? If not, I'll go to the question to Valerie, who presented, I think it was one of the first ones. In fact, it was the first presentation at this session. So can you go into a little bit more detail about the method? I believe that you derived a moment tensor for a small Latvian event in Latvia. So what method did you use for this? Since it's a small event, usually moment tensors are quite appropriate for larger events. What kind of data did you use, and what kind of method did you use for this?
This method we use common with my colleagues from Ukraine, Dmitro Malitsky. This method was created by Dmitro Malitsky, and we the first time use this method in East Baltic region as part of East European platform. And as the main interest was to induce earthquake. And sorry, in our region, we found only one induced earthquake in Lithuania territory. And we use this method for estimate induced earthquake with magnitude, local magnitude 2.6. And individual Dmitro Malitsky use this method in Canada, Alberta province, and in this place, his estimate with help his method induced earthquake with magnitude 4.0.
Okay, thank you very much. Just to remind, when you are speaking, you are encouraged to turn your video on. I think I mean, there are various bandwidth issues with people who are far away, but maybe when we share, it's a bit more difficult. But when you're speaking, it's fine to turn your video on. Umar, did you have a question?
Hello?
Yes.
Actually, the question I wanted to ask Zule Huma, you have already put it across to her, so I don't have a question.
Okay, thank you.
Yeah.
I do have a question for you, though.
Okay.
So, can you speak to the level of instrumentation in Western Africa in general? I know Western Africa is in general not a very seismic area compared to many other to Eastern Africa, for instance. Is that situation changing, and do you see perhaps low-cost solutions that would be a solution to this this problem of relative lack of instrumentation there.
West African region is a stable crustal region in terms of earthquake activities. Over the years, various earthquake monitoring observatories have been deploying instruments, earthquake monitoring equipment, for instance, in Nigeria, Ghana, and Cameroon. But to a large extent, they are still inadequate to monitor, especially the microseismicity, microseismic activities in the region. So we are actually looking at the possibility of collaborating with international agencies, organizations to densify instrumentation in West Africa to enable us at least understand the seismotectonic activities or nature of the region, because so many strange earthquakes are happening in the region now without adequate knowledge as to why they are occurring. For instance, in Nigeria, we'll be recording so many intra-plate earthquakes without any visible link to an active effort within the country. Same to some parts in Ghana, in northern Ghana, but in southern Ghana, at least there are well-constrained faults that are causing earthquakes in the southern part of Ghana. In Cameroon, we have the volcanic line. Of course, every now and then we are experiencing earthquakes along that region. So we are going into collaborations with amongst the African countries, especially where you have earthquakes prominent amongst Nigeria, Cameroon, Ghana, so that we see how we can also monitor along our borders. For instance, Nigeria and Cameroon, we have forged a collaboration on how to install seismic and geodetic equipment along our boundary to monitor geohazard. Cameroon too, we also now we exchange data and knowledge. We organize the conferences together, and things are really improving. But then instrumentation is actually still the issue that we need to densify. And another serious issue confronting earthquake research in West Africa is the issue of the willingness by geoscientists or the operators of seismic operators to share data. We have so many individuals now buy seismic equipment, universities, not necessarily research institute. But the issue is they are not willing to share their data with the rest of West Africa. And I think this should be encouraged so that we have a better outlook of what is happening in West Africa. Thank you very much.
Right, thank you. Yeah, maybe part of the problem is the vegetation cover that prevents you from seeing any fault traces and things like that. Is that one of the issues over there in terms of?
Actually, the vegetation cover is not actually the issue, because in some areas we have been able to map some faults using geophysical and geological approaches. Though they are not active, but you can see that they actually have faults. So they are open. They are not covered by any vegetation, as you may wish to suggest.
All right, thank you. Thank you very much, Umar, for a very comprehensive response and over seismicity in West Africa. That's very interesting. And I'm sure there's a lot to learn about it from added instrumentation. Valerie has a comment on the chat, and I can maybe try to paraphrase it. He's encouraging those of you who do not have yet an NDC in your country to try to approach the authorities to try and do this. He also mentions that it's not an easy thing to do, so and that they may listen to international organizations. That's certainly something we are trying to do very hard here. Part of our mission is to do capacity building, and so we do encourage creation of NDCs, and we provide support for this. So yes, Umar has a
I just wish to put across a request because we are also looking at the possibility of integrating our monitoring. Are you hearing me, Roland?
yes.
Okay. Integrating our monitoring system in Nigeria with infrasound low-cost sensors. I do not really know the possibility of Nigeria collaborating with CTBTO to get this done, because so many earthquakes are happening in Nigeria and we are not able to record. They said that you just experience vibrations, but we have stations not even far away from where the vibrations occurred, and you discover you will not be able to record the earthquake. So is it okay if we incorporate infrasound technology into our monitoring system in Nigeria?
This is a question for us, or maybe Shahar is an infrasound specialist, can speak to the technical issues there.
I'm sorry, I missed.
Your experience. I think Umar was asking if you could integrate seismic and infrasound. Did I get that right, Umar?
Yeah, basically we have seismic stations, and we're also looking at the possibility of integrating them with low-cost infrasound sensors to enable us monitoring, maybe to monitor micro-seismicity in the region, especially where we have delineated some faults.
Yeah, so it's definitely possible. We are now also moving in the Netherlands towards equipping many of our seismic stations with an additional infrasound sensor. And it really depends on what infrastructure you already have at the existing stations. If you have room in the cabinet and available channels in the data loggers, adding an infrasound sensor is a pretty straightforward thing. And nowadays, you can also devise a wind noise reduction system by using porous hoses or different contraptions. And yeah, we're doing this.
Okay, thank you very much. Thank you.
Thank you. And Umar, I would encourage you as well to get some training, and we provide some training. The capacity building section at the IDC provides training on this, and also the NDC in a box software contains software to process infrasound now. So that's another avenue you can explore. I noticed we have Mr. Dmytro Malitsky, who is on as well. I think he's a co-author with Valerie. If he wishes to say something, also is welcome, or ask questions. Hello, Mr. Malitsky.
Or Dmytro Malitsky can give question, right question, and he may answer in this question, I think.
Okay, thank
you. Hello, Shahar, can you hear me?
Yes, indeed.
Yeah, I just have a question for you related to this infra-based intensity map. So I think this method, as I understood, can be applied to inhabited area, depends on the distribution of the infras on the stations. So how do you think that this intensity map method can be applied for habitated area, which is more important than inhabited area? Do you think that a possibility, or?
I don't think there is a difference. The map that we show, it's not for an inhabited area. It was for Haiti. So you see that the region we cover with this acoustic intensity map also covers many cities and villages on Haiti. And we've done similar work with these back projections and estimating the acoustic intensity for nuclear explosion, namely the latest DPRK experiment in 2017. And we also did this for earthquakes in Italy. So this is already quite a developed method. It's not an operational tool yet, but we have shown several times that this method of back projection of acoustic intensity calculated from infrasound detections works.
Great, thank you.
All right, any further questions? I have a question for Professor Schenker. Thank you very much for your comprehensive contribution. How much importance would you lend to the local coast geometry and bathymetry in the wave amplification factors observed for the two 2018 events that you mentioned on your poster? So what is the impact of the coastal geometry? And
yes, Professor Brass. Local geometry of the coast is very important for the risk mitigation. So local coast must be modeled and investigated for the disaster impact. For the remedy for that, to reduce the disaster from the tsunami, is to grow mangrove tree along the coast, so that tsunami impact may be reduced. And for the human being, half kilometer of the area along the coast should be kept barren, and there should be no restaurant, no hotel like that. And where there is already existing this infrastructure, then there must be retaining wall to break the tsunami impact for this. And another mitigation can be done by just tsunami warning centers. When the earthquake occurs, just alert the people along the coast. I think this is the process can be done to reduce the impact.
thank you. Prevention then is an important thing there. Very good. Would you see that? I mean, is it possible, do you think, to predict with precision, with a high level of precision, high degree of precision, where a tsunami, depending on where the tsunami earthquake is, it's possible to predict the zones of high amplitude with the modeling?
High amplitude of the tsunami can be predicted if somebody just give the exact information of the earthquake location. If it is along the coast, then its generation can be predicted. Development of tsunami is generated, and this tide gauge and everything sitting at the coast, they will give the continuous monitoring of the level of the rise of the this ocean water.
Thank you.
So it is possible.
Thank you. All right, I have a question for Shahar. In terms of the the presentation you made. I was very impressed by the fact that you can use, I believe you use one single infrasound station. So my question is, if you had an additional one, would that reinforce your interpretation?
Yes, of course. Of course. So we also discussed this in more detail in the paper, and we showed that when you use a single array, then you have a resolution problem in terms of your back azimuth. Because let's say you have an error of 1 degree in your back azimuth projection, the further the array is, the larger this error is going to grow. And when you have an additional array, then the error, and let's say from a different, looking at the same source from a different angle, then these cross bearings actually mitigate some of these back azimuth errors. So of course, the more arrays you have that detect the event, the more robust the map is going to be. We used this specific case because we thought it's a really interesting case where there were no seismometers on the island, but there is very good and detailed documentation of the damaged buildings and slope failures and etc. On the ground. And we thought it would be an interesting example to show the potential of this method.
All right, thank you. Thank you very much. Okay, are there any questions? Okay, there is one question. Okay, in the chat. Let me read for you. And this is again to Shahar. Could you kindly share your publication on microseismicity monitoring using infrasound? Yeah, okay. So this is from Umar, and he would like to get the reference to your publication.
Yeah, of course, it's not a problem if you go on my ResearchGate page or on our CanMI personal pages. You have access to all the publications we publish, either open access or we post the preprint. So all of this is readily available.
Okay.
Right. Thank you very much. Yeah. So ResearchGate, that's a good way to connect. Yeah, so I had just one last question for Shahar again. What is the threshold where infrasound, in terms of magnitude, what is the threshold you think where infrasound becomes useful? I imagine the larger the event, the more significant the contribution may be, but do you have a feel for that? And I understand that it's probably distance dependent again also.
Indeed, it depends on a lot of different factors. It depends on the distance from the earthquake. It depends on what the atmosphere is doing at the time of the earthquake. We have shown for earthquakes in Italy that 3 different earthquakes in the same region with the same mechanism and roughly the same magnitude will be detected very differently at the same array depending on the time of the year. So we looked at 3 earthquakes all around the same region, and these earthquakes were spaced 2 or 3 months apart, before equinox and after equinox. So the circumpolar vortex is changing its direction. And these events are detected very differently, even though they're essentially the same. The distance is the same, the magnitude is the same, the depth is the same, but these events are detected very differently. Similarly, if you have a very very good ducting to the event, I think that we can detect even magnitude 3 earthquakes from hundreds of kilometers away. And it of course depends on how close to the surface this source is. So for example, for the Beirut explosion that happened, because the source was very impulsive and very close to the source, even though it was equivalent to a magnitude 4, I believe. It was detected very, very far away.
All right, very good. We're coming to the end of our session. And thank
Please,
you very much again for your contributions. We do have to leave the space to someone else, so unfortunately we'll have to leave soon. But I would encourage you to go on the video rooms. So there are rooms available. This is on Super Event, right? It's on Super Event. So you have video rooms that you can join and continue the conversation between yourselves without being broadcasted. So thank you again, each and every one of you. And I think we had a couple good discussions here. Yeah, Umar, you want to say something too?
Yeah, I just wanted to say that I'm going to follow you up with the issue of training in infrasound technology. I know I have your contact. I will follow you up with that. Yeah.
Very good. I encourage you to do so. Okay, thank you very much, everyone, and have a good evening.
I will be in the video room if
Thank you very much.
discussion
Thank you
there.
very much.
Very good.
See
Thank
you
you.
all. Thank
Yeah.
you. Bye-bye.
Yeah. Bye-bye.
Bye-bye. Bye-bye.
See you.
Mhm.
You. Bye.